Okay, so here's a guide that will help you with question 2 for week 10. And the question reads that at a major credit card bank, the percentages of people who historically apply for the silver, gold, and platinum cards are 70%, 20%, and 10% respectively. In a recent sample of customers responding to a promotion, of 200 customers, 122 applied for silver, 52 applied for gold, and 26 applied for platinum. Is there evidence to suggest that the percentages for this promotion may be different from the historical proportion? And we have parts A to E to complete. Part A is asking us if the customers apply for the 3 cards according to the historical proportion, about how big on average would you expect chi-square statistic to be? What is the mean of the chi-square distribution is what that is asking. Now, textbook help, it suggests that the chi-square, the degrees of freedom is going to be k minus 1, and in this case we have 3 possibilities for k. So k minus 1 is going to be 3 minus 1, which is 2. Now this expression also textbook help. Moving on to part B, we're asked to calculate chi-square statistic for the data. Now this result is here calculated already. Let me delete it and do it live for you. This is what we're given. Now importantly, when you're substituting the observed value and the expected value, they both must be counts. So this 70% is what is expected, but what is that in terms of an actual count? It's going to be 70% times the total, which is 200. So of the 200 people sampled, 70% is 140, and that's what you would expect to have applied for silver. The same for gold is 20%. Multiply that by the total, 200. 10% multiplied by the total, 200, so that's 20. So these values here are the actual counts. This is the proportion for what was expected. So this is the traditional proportion, and this is what we would expect if we sampled 200 people, which is what we did. Now, to work out this expression, we need to find the observed minus the expected, square that difference, then divide it by the expected, and then for each of the 3 we will find that expression and then find the sum. So let's go and do that. I'm gonna do observed minus expected, and I'm gonna square that. Let me just put all of the numerator in a bracket, and then I'm going to divide that by the expected, which is 140. Then I'm going to go ahead and copy that cell across, do the same calculation for gold as well as platinum. Then I want to find the sum of those 3, which is what this sigma all cells is saying. So 7.71 is what we get in this case. The computed chi-square statistic is 7.71. Now this is much larger than the expected value of 2. Moving on, I think we're asked to state the alternative hypothesis as well as the null hypothesis. The null hypothesis is saying that these customers are applying for cards with the same traditional proportion. Alternatively, these customers are not applying for cards with the same traditional proportion. Alright, simple enough. Since the test statistic is greater than the mean, we reject the null hypothesis and conclude that these customers are not applying using traditional proportions. Chi-square tests are always one-sided. The chi-square statistic is always going to be positive, and a large value provides evidence that the null hypothesis, because it shows, evidence against the null hypothesis, because a large chi-squared value shows that the data is not a good fit for the model. Now, to calculate the critical value, this website, which is in the link, proves useful, and this is what it looks like. When you get to the website, you will have to input your degrees of freedom. Make sure you click on calculate critical value, and then this is set at 95%, so that's your degree of certainty you are looking for. Hit calculate chi-squared and it produces the 5.991 value for you. Alright. Now, to reach a conclusion about the null hypothesis, you compare the statistic for chi-squared to the critical value. If the statistic is greater than the critical value, then you reject the null, which is the case here. The statistic we got was 7.71, critical value was 5.91. Calculated is greater than critical, so we reject the null hypothesis, which means that this guy here is true. Alright, so hope this helps. If you have any questions, feel free to reach out to us. Thank you.